Hello everyone, welcome back in this last conclusion of this chapter, that is distribution of ocean and continents. I hope you all are very well and you have completed the all the three parts, that part 1, part 2 and part 3, where we have vividly discussed about the concept of that is the for formation of the continents, that is division of the continents, earthquake, volcanoes, after that various movement, convection current, how it flows, and the characteristics of mantle, different types of forces, and in the last we have discussed about the concept of the introduction of plate tectonics. So finally we have discussed that and understood the concept of ocean and continent, and they have two separate domains in geography or geomorphology or geology. Okay, geography, geomorphology and geology. So these are specialized branches which used to study this kind of dynamicity of our planet. So today is the last lecture of the distribution of ocean and continent, and today's topic is about plate tectonics and movement of Indian plate. Myself Pratik Chakraborty. Let's begin the journey. Whenever we used to say about plate tectonics, since the advent of the concept of sea floor spreading, the interest in the problem of distribution of ocean and continents was revived. It was in 1967, Mackenzie, Parker, and Morgan independently collected the available ideas and came out with another concept termed plate tectonics. A tectonic plate, is also known as lithospheric plate, is massive, irregularly shaped slab of solid rock, generally composed of both continental and oceanic lithosphere. We know there are two separate parameters. One is the ocean basin or the mid-ocean basin, and the continent. So both of them having lithosphere. Okay, so plate move horizontally over the asthenosphere as rigid unit. My question is to use that, what is asthenosphere? We have covered this topic. Try to write the answer. The lithosphere include the crust and top mantle, with its thickness range varying between 5 to 100 km in ocean part and about 200 km in continental part. So these statement we have discussed in part 2 video, that why in oceanic part it ranges from 5 to 100 km, very short range, and in continental part having a very high range, that is 200 km. What is the reason? A plate may be referred to as continental plate or oceanic plate, depending on which of the two occupy a larger portion of the plate. Pacific plate is largely known as oceanic plate. There is a reason, because the entire Pacific plate is ocean only. There is no such continent. And the Eurasian plate is called the continental plate. Eurasian plate means which plate? The Indian plate that is submerging inside the plate, due to which Himalaya is rising. That is Eurasian plate. The theory of plate tectonic proposes that the Earth's lithosphere is divided into 7 major and 7 minor plate. Young fold mountain ridges, trenches, and fault surrounded these major plates. So 7 major and 7 minor plates. So let's see what are the 7 major and 7 minor plates we have. The major plates are as follows: Antarctica and the surrounding oceanic plate. And in this plate we having North American plate, the first one, North American. So with Western Atlantic floor separated from South American plate along with Caribbean island. Okay, that is North American plate. So let's see in the map North American plate. You can see easily in this part, that is the North American plate. It includes mostly entirely North America, present Greenland, and some parts of Caribbean Peninsula. This little plates is there. Okay, so this is North American plate. After North American, we having South American plate. So let's see in the map. This you can see South American plate. Okay, this plate many a times it's known as square plate. Okay, because it's resemble this shape, square plate. Okay, that is South American plate. Next we having the Pacific plate or the oceanic plate. Okay, Pacific plate we can see this part. Okay, this is the Pacific plate. It comprises mostly of Pacific Ocean. Next we having India, Australia, New Zealand plate. Okay, so India, Australia, and New Zealand, this plate, okay? India, Australia, New Zealand plate, okay? It's a very long stretched plate, okay? India, Australia, New Zealand plate. Next, we having Africa with Eastern Atlantic floor plate. Africa with Eastern Atlantic floor. Okay, this ridge. This is the ridge line, Atlantic mid-oceanic ridge. You have studied in part 3. Okay, this is the African plate. Next is Eurasia and adjacent oceanic plate. So Eurasia and the adjacent oceanic plate. Okay, this is the Eurasian plate. Some important minor plates you can see. First is the Cocos plate between Central America and Pacific plate. So Cocos plate, okay, between Central America and Pacific plate. Okay, that is Cocos plate. Next is Nazca plate, very important, between South America and Pacific plate. Okay, between South America and Pacific plate. Next we having Arabian plate, mostly Saudi Arabian landmass. So Arabian plate we can see this place, okay, mostly Saudi Arabian landmass, okay. Next we having Philippine plate. Philippine plate is here, okay, Philippine plate between Asiatic and Pacific plate, okay. Next is Caroline plate between Philippine and Indian plate. So there is Caroline plate between Philippine and Philippine plate, it's here, okay. And lastly we having the Fuji plate or Fiji plate, that is northeast of Australia, okay, that is Fuji plate. So here Fuji plate you can see. So here I think Fuji plate you can see most probably, no, Fuji plate is not visible here, okay. So these are some of the minor plates we can see in this map. This map is from NCERT. So in this map, three important zones we can refer. First is the that is the convergent zone. Convergent means coming together, okay. So you can see this line is the convergent zone. The Himalayan part is their Eurasian part. They're coming together, subsidizing, okay. So these teeth like structure is convergent boundary, okay. Convergent boundary is very much problematic because they create earthquake many a times, okay. And Pacific ring of fire is an example of this kind of thing. And next you having divergent boundary, that means separating, okay. These two plates are separating away from each other, that is divergent plates, okay. So in this line, in this map, you can see the divergent plate. And lastly we can see the transform boundary. Transform means that it will move perpendicularly, okay, left and right, okay, perpendicularly it will move, that is transform boundary. So this is the generalized major and minor plates of the world you can see through this map. Next, the origin and the concept of plate tectonics. These plates have been constantly moving over the globe throughout the history of the earth. It is not the continent that moves as believed by Wegener. So Wegener continental drift, I think you know, you just recall once, okay. So in continental drift, what Wegener thought, that all the landmass is a unified landmass, that is Pangaea, and there is one single water body, Panthalassa. And slowly this Pangaea divided into Gondwana land and Laurasia land, and after that further divisions takes place. But plate tectonics is doesn't belongs to Wegener concept. Continents are part of plate, and what moves is plate. So many a times what we used to say that continents are moving in Wegener theory, but here in plate tectonics theory they used to say that continents are not moving, plates are moving. Moreover, it may be noted that all the plates without exception have moved in geological past and shall continue to move in the future as well. Wegener had thought of all the continents to have initially existed as a supercontinent in the form of Pangaea. So, as Wegener imagined that there's a supercontinent Pangaea, but in plate tectonics, Pangaea is not a supercontinent; it is rather a plate, a unified plate, and suddenly the plate broken completely and divided into several pieces. You can imagine like that. However, later discoveries reveal that the continental masses resting on the plates have been wandering all through the geological period, and Pangaea was a result of converging of different continental mass and were parts of one or the other plates. So what happens? Later discoveries have showed that Pangea was a result of converging of different continental mass. That Pangea that Wegener imagined, it is a converging continent. Many continents and converged, but there is each and every continent is demarcated with their plates, with their unique identity. Scientists using the paleomagnetic data have determined the position held by each of the present continental land masses in different geological periods. So the map that I have showed you here, this is not a hypothetical map. These maps has been made by the geologist, by the geomorphologist, and they have prepared it through sensors, scanning, and all the things. After that, they determine that yes, we having plates. Okay. Next important question is that all the plates they have their own identity, and they have their boundary also. So plates, there are three types of plate boundary. First concept is the concept of divergent plate boundary. Okay, divergent plate boundary. So what is divergent plate? Where new crust is generated as the plates pull away from each other. See, the plates are pulling away from each other and creating a ridge or a gap where the magma will come and spread. The sites where the plate move away from each other are called spreading site. The best known example is mid-Atlantic ridge. Okay, at this the American plates is are separated from Eurasian and African plates. So this event we can see from divergent boundaries. Next we having the concept of convergent boundaries. Convergent means coming together. Okay, where the crust is destroyed as one plate dived under the another, that means subduction. The location where shrinking of plate occurs is called subduction. Shrinking means slowing down, okay, reducing. That India plate is an example, that going beneath the Eurasian plate. Okay, and many a times earthquake, volcanic eruption, these things we used to see in this plate. Okay, there are three ways in converging. First is the between ocean and continent. We can see this thing between two ocean and between two continent. These are the three important criteria of convergent boundary. Next and last type of plate boundary that we have is the transform boundary. Transform boundary, the plates will move perpendicular. Okay, where the crust is neither produced nor destroyed as plate slide horizontally past each other. Transform faults are the planes of separation generally perpendicular to the mid-oceanic ridges. Okay, as the eruption do not take all along the entire crest at the same time, there is a differential movement of portion of the plate away from the axis of the earth. Also, the rotation of the earth has its effect on the separated blocks of the plate tectonic. So this plate is particularly, you can say that earthquake doesn't it's a very negligible earthquake. Little bit possibilities are there. San Andreas fault is an example of transform fault. Okay, you can search it in Google. San Andreas fault is an example of transform boundary. Okay, so these are the three important boundaries that we have. Next, the important question that comes in our mind, that rate of plate movement, that we didn't feel, as we used to say that plate movements are dynamic because every day it is going on convection circulation going on inside the earth. The strip of normal and reverse magnetic field that parallel the mid-oceanic ridges help scientists determine the rate of plate movement. This rate varies considerably, particularly geophysicists, they used to study the magnetic field and magnetic properties. The Arctic ridge has the slowest rate, less than 2.5 centimeter per year, and the East Pacific rise near Easter Island in the South Pacific, about 3,400 km west to Chile, has the fastest rate, more than 15 centimeter per year. So, with this data, by studying the magnetic field, we can easily understood the concept of that yes, like this way the plate is moving. And with this explanation, we can say that Himalaya is growing. Why Himalaya is growing? Because Indian plate is subsidizing inside the Eurasian plate, and the pressure is continuously creating, and every year approximately 1.2 centimeter to 1.5 centimeter per year it is growing. Himalaya. Force for plate movement, that what are the important forces are there for the plate movement? First few things are that the mobile rock, that is movable rock beneath the rigid plates, is believed to be moving in a circular manner. The heated material rises to the surface, spread and begin to cool, and then sinks back into deeper depths. This concept is particularly supported by convection current. That day I have told you that the magma just above the core heated up. It moves up. When it's moving up beneath above that, there is ocean. So when it's moving up, suddenly the temperature falls. Again it comes back. Again it warms. Again it moves upward. Again it cools down. This circulation is going on, and this creates a convectional cell and convective flow. The cycle is repeated over and over to generate what scientists call a convection cycle. Heat within the earth comes from two main sources. One is the radioactive decay and residual heat. Arthur Holmes first considered the idea in 1930, which later influenced Harry Hess thinking about sea floor spreading. The slow movement of hot softened mantle that lies below the rigid plates is driving force behind the plate movement. So finally we have evidence that why the plates are moving, and this evidence is very much important. Next part we are moving is the movement of Indian plate. So till we have understood that yes, there are a lot of plates and all these things and that thing, continental drift theory we have understood, and we will use this concept continental drift theory here to understand the movement of Indian plate, and this theory is very much important. Okay, so that is an this is an first concept, that Pangea is dividing. Pangea is dividing. Okay, and what is happening? See, there's a slow movement of Indian plate. You can see drifting. Okay, which countries are there? You can easily identify. Australia is also moving at that side, particularly in the northwest, east, northeastern direction. Sri Lanka was there. After that, some parts of other nations, that is Madagascar, and these parts are also there. See, the movement is going on like this. Okay, the movement is going on. Okay, okay. See how Indian plate is moving towards the Eurasian plate. Okay, just 1 minute. So like this way, Indian plate is moving towards the Eurasian plate. See easily. Okay, visible everyone, and see when it is moving towards, this is Indian plate particularly, you can see here, and this is Eurasian plate, and between this we have a vast water body, and in this water body sediments are there. Okay, sediments are there. So when Indian plate is going towards this side, the water gets diverted, the water getting dried off completely, and all the sediments started moving upward because squeezing used to take place. Squeezing of sediment used to takes place. See, like this way. And when suddenly the Indian plate submerged inside the Eurasian plate, the Himalaya started. Formation of Himalayas. Okay, that is the present day Himalaya we can see from here. Okay, so this is a movement of Indian plate. So now we will see that how the Indian plates have moved and what are the key features of the Indian plate. The Indian plate includes peninsular India, the oldest landmass, and the Australian continental portion. The subduction zone along the Himalayas forms the northern plate boundary in the form of continent and continent convergence. So first thing what happened, convergence taken place, Eurasian plate and Indian plate. In the east it extends through Arakan Yoma, or it is also known as Arakan Yoma mountains of Myanmar, towards the island arc along the Java Trench. The eastern margin is spreading site lying to the east of Australia in the form of oceanic ridge in southwest Pacific. The western margin follows Kirthar mountain of Pakistan. It further extends along the Makarana coast and join the spreading site from the Red Sea Rift southeastward along the Chagos archipelago. The boundary between India and Antarctic plate is also marked as oceanic ridges. Oceanic ridge, particularly divergent boundary, running in roughly west-east direction and merging into the spreading site, a little south of New Zealand. So particularly what are the things has been discussed here, the geographical locations of different specific relief features. India was a large island situated off the Australian coast in a vast ocean. The Tethys Sea separated it from Asian continent till about 225 million years ago. India is supposed to have started her northward journey about 200 million years ago, at the time when Pangaea broke. India collided with Asia and about 40 to 50 million years ago, causing rapid uplift of Himalayas. So, with this animation, it is clear that how India is moving and what are the reasons behind this movement. And finally, we can see that yes, this is the present day India and the Himalayas. Okay, all the features of Himalayas we can see. So this is the movement of Indian plate particularly, and like this way the formation of Himalaya is there. Okay, movement of Indian plate. So in this image you can easily recognize the India today and early India and how it moves with the years. I have mentioned it. Okay, so it is easy. The position of India since about 71 million years till the present are shown in the figure. It also shows the position of the Indian subcontinent and the Eurasian plate. About 140 million years before the present, the subcontinent was located as south as 50 degrees south latitude. The two major plates were separated by the Tethys Sea, and the Tibetan block was closer to the Asiatic landmass. So, Tibetan portion was also there, and after that, when it strikes, it's a combinedly and a jointly landmass formed, and Tibetan peninsula formed. During the movement of the Indian plate towards the Asiatic plate, a major event that occurred was the outpouring of lava and formation of Deccan troughs. So, in Deccan Plateau in India, you have studied about Deccan Plateau, Deccan Trough formed. These started somewhere around 60 million years ago and continued for a long period of time. Note that the subcontinent was still close to the equator. From 40 million years ago and thereafter, the event of formation of Himalayas took place. Scientists believe that the process is still continuing and the height of the Himalayas is rising even to this date. Hence, due to this subduction zone, we are in a very danger earthquake zone, and it is continuously the process is going on. That's the story of the formation of Indian plate and movement. So I think through animation and through graphics it is easy to understood that you have understand all the concept. My suggestion is to you that whenever you are reading this concept, please refer atlas map and any other Google maps that you have, because the Arakan Yuma mountain range, Red Sea, after that Tibetan plateau, after that these particular things you have to remember through maps only, otherwise it is difficult to understand. Thank you everyone. So this chapter ends finally. I hope you have enjoyed all the lecture series whatever has been uploaded, and very soon we will upload all the other lecture series in a new and a different way. Please revise this chapter because these chapters are very important. Take care. Goodbye.